Calculus Kids. This is Dr. Callahan for week 8, Friday. Yay, we made it to the weekend. So go ahead and pause the video to take a look at the following questions. Okay, you can go ahead and take a look at the warm-up. So today is actually the third day that we're going to go over chain rules. And so take a look at our breakdown as to what we're doing. Just as a friendly reminder, last time I saw you guys, we did go over the Math Excel Wednesdays quiz. So make sure you guys are working on that because it is due in a week. In addition to that, you guys had some of the textbooks or questions from the textbook that kind of summarize what you did with trig derivatives in alongside with product rule and quotient rule. And if you have any problems, remember there's a video right here at this link that you can go ahead and watch. And I kind of go over these questions step by step. All right, so today, this is a breakdown of what we're going to be talking about. This is our third day with the chain rules. I'm going to go over 5 examples in class. There's 5 examples in your guided notes on advanced problems involving chain rules. And then I have some practices for you guys to do accompanied by a video. And if you're with me in person, we're actually going to do a poster rotation with more advanced chain rule problems. All right, so let's go and take a look at your guided notes. You have 5 pages of guided notes today. So starting on week 8, Friday, this is the first page. Here are some practice problems from the textbook on chain rules and quotient rule and product rule that you can go ahead and practice with. These are the answers to the 5 examples we're going to cover in class. Some of them look fairly simple. I'll go over the more difficult ones. And then I have a calculus puzzle that says, why did Sir Isaac Newton reuse a glass of wine before sitting down to formulate the rule for differentiation? And if you take a look at this, the questions are up here, and then the answers are following that on the bottom. These are some additional examples we will be practicing as well. And this will be the template you will use for the poster rotations if you're in class with me. And these are your guided notes for the 5 questions. So this is a chain rule of my notes, and then also the steps that you guys would use for the following 5 examples. And of course, some additional practice problems if you would like some extra practices alongside with the answers right next to it. Everybody is kind of at their own level at this point. All right, so with that said, let's go ahead and get started. I would suggest you pause the video, go ahead and try these 5 examples and see how far you get. The answers are provided for you right here. All right, I'm going to go ahead and go over example 2 because example 2 is a harder version of example 1. All right, so you have f of x is equal to this radical cube root, and you don't want to have a radical cube root because you can't find the derivative that way. So I'm going to put this from radical form to an exponential form, x squared minus 1. And remember, whenever you do an exponential form, it's always going to be the power divided by the root. Your root here is a 3, and your power here is a 2. Sometimes students get that backwards, and they put 3 over 2, which really is a 2 over 3. Now, you can go ahead and apply the power rule, bring that down. So f prime of x is going to be 2/3 x squared minus 1 minus the 1 on top for the exponent, which is a 3 over 3. And you should get a negative 1/3 times. And here is where you need to multiply by the chain. So the derivative of x squared minus 1 is a 2x. And so if I were to rewrite this, I will have the 2 times the 2, which is a 4x, 3 on the bottom. Put this down to the denominator, so you have a positive 1 over 3, and put this back into the radical form. And that is your answer for f prime of x. Now, if it makes you feel a little bit better, because sometimes people have difficulty seeing the chain rule, another thing that you can do is you can say, let u equals x squared minus 1. Then you have u prime to be 2x. So then if this right here is u, then remember f prime of x is going to equal to 2/3 u to the negative 1 over 3 times u prime. Whenever you involve a u with a chain rule, there's always a u prime. So then after you finish that, if it looks better that way, make sure you replace the u back. So you have f prime of x is equal to 2 over 3 x squared minus 1 to the negative 1/2 times 2x. And then you just algebraically modify that back to the f prime of x. So either way works. Some people think that if you just leave it as x squared minus 1, it looks really messy and they forget to do the u prime. So if this way is better for you, you can definitely do that. And just with every chain rule, substitute the chain with the letter u. And that way you don't forget the u prime. Okay, let's take a look at this one here. So already I can see that it's going to be a power rule with a derivative of a chain rule with a quotient rule. So bring that 3 down. Y prime equals 3 times x minus 1 over x squared minus 4 squared times, and this is where your u prime is, which is the chain to this. So a lot of times, like I said, people get a little bit confused with all of these writings. So if it makes you feel better, you could say y is equal to u to the 3rd power. Y prime is equal to 3u squared times u prime. So then you got to say, let u be x minus 1 over x squared minus 4. Then u prime equals, and this is where you will have to do the quotient rule. So you will say f is equal to x minus 1, f prime equals 1. G is equal to x squared minus 4, g prime is equal to 2x. And I know you're like, well, before you go any further, Callahan, can't you cancel anything? Unfortunately, I cannot, because on the bottom, the only thing I could do is the x minus 2x plus 2. Neither of those options are going to cancel with the x minus 1, so you're kind of stuck with that. But I did think about that, so it's a good thing that you considered that to see if you can avoid using the product rule. Then g squared will be x squared minus 4 times x squared minus 4. So you will have to FOIL that to x to the 4th power. Outer is a negative 4x, inner is a negative 4x, so combine outer inner is a negative 8x squared. Last is a negative 4 times a negative 4, which is a 16. And that is your g squared. So then with my u prime, I want to go ahead and kind of move it over here and work it over here, sorry. U prime is going to be f prime times g minus f times g prime over g squared. So f prime times g is 1 times x squared minus 4. So x squared minus 4 minus. Now you got to be careful with that because of this minus is for this entire piece of f times g prime. So f is x minus 1, g prime is 2x. So I will go ahead and distribute the 2x into the x minus 1. So that's 2x squared minus 2x. And then because of this negative, it's going to be a negative 2x squared plus 2x. Before I do anything else, let's go ahead and combine like terms. So negative 1x squared plus 2x minus 4 all the over g squared, which is x squared minus 8x squared plus 16. And I know you're thinking, well, can we maybe factor the top and the factor the bottom? So far, that's a really good thought, but unfortunately, you cannot because I already can see it. If you factor out the negative 1 from the x squared, you will have a negative 1 on the outside, positive x squared minus 2x plus 4. And I'm thinking, okay, what times what gives me a 4, but when I add it together, it gives me a negative 2. None of the options work because if you think about it, 2 and 2 does not give me a negative 2. Negative 2 and negative 2 doesn't work. 4 and 1 doesn't work. Negative 4 and negative 1, neither of those choices work. So there's nothing I can factor, unfortunately. And so I'm just stuck with this right here. So this is what u prime equals to. So now that I have u prime, I can complete my derivative. So y prime is equal to 3u squared times u prime. So u, I'm going to go ahead and replace everything back. U squared. Okay, good. I haven't stopped doing anything. That scared me a little bit. U squared, excuse me, is going to be you had u as this part right here. So then I will have x minus 1 over x squared minus 4 squared times u prime. U prime is right here. So that will be a negative x squared plus, actually, you know what I'm going to do is I'm actually going to take this negative 1, multiply here, so it becomes a negative, and then I'm just going to take inside this part to have it as a x squared minus 2x plus 4. All the way over x squared minus 8x squared. Hold on, 8x squared. Uh-oh, something's wrong here. Should not be u prime. Oh, sorry. Made a little typo. I'm like, shouldn't be a 2, should be a 4. Sorry about that. So let's change that to a 4 minus 8x squared plus 16. Yeah. So at this point, you can leave it like this, or if you want to make this a little bit better looking, because unfortunately, there's nothing that we can really cancel. So you can rewrite it as negative 3 x minus 1 squared times x squared minus 2x plus 4 over x squared minus 4 squared times x to the 4th minus 8x squared plus 16. And I think that's as far as you can go. If you really want to FOIL it, you could FOIL it, and you could take your trinomial up here, multiply by the trinomial here, and then combine like terms. But I think for sake of time, this is good enough. And that is your answer for example 4. All right, let's take a look at example 5. With example 5, first thing I notice is I have a radical. So I'm going to rewrite it to x squared minus 1 to the 1/2. And then I'm going to see if I can maybe avoid using the quotient rule to see if I can combine the numerator and denominator together. And unfortunately, I just don't see anything that I can do. I mean, you could technically move this one up. So you have y equals x times x squared minus 1 to the negative 1/2. But then you still have to do the product rule. So I'm not necessarily sure if that's going to be easier or not. But you can do that though. So why don't we go ahead and try that? and see if it is easier, because we already did the quotient rule once, and let's now try the product rule. So y prime is equal to f prime times g plus f times g prime. So then let's on the side write f is equal to x, f prime is 1. G is x squared minus 1 to the negative 1/2. G prime is, apply the power and chain rule, negative 1/2 x squared minus 1. Make sure I'll put it here, minus a 2 over 2. You have to be careful because when you do the g, you don't want to include the negative 2 over 2 because that's, it looks like it's together, but it's not. It's going to be a minus 3 over 2 times the chain of this. What is the derivative of x squared minus 1? It's just going to be 2x. Now, you don't want to leave your g prime in this big mess when you plug it back into the equation, so let's simplify this and make this look prettier before we attempt to put it back into the formula. So I notice that the 2 on the top and bottom, so that cancels. So my g prime is equal to negative x on top. And then I have an x squared minus 1 to the positive 3 over 2 in the denominator. I don't want to put that back into a radical form just yet because you never know, you might be able to combine something here, when it's an exponential form. And finally, in the final form, you can go ahead and convert it back to a radical form if you would like, but for the time being, just keep it in exponential form. All right, let's go ahead and replace this. F prime times G, so that's 1 times, hold on. Sorry, I'm gonna move this browser over a little bit. Okay, what just happened? Okay, there we go. So that's just going to be 1 over x squared minus 1 to the positive 1/2. I'm going to keep it like that. Plus, you want to do f times g prime. So f times g prime, which is this right here. X times a negative x is going to give me a negative x squared. So I'm going to change that to a minus x squared over x squared minus 1, 3 over 2. Okay. So I can see that I have two fractions here, and my goal is to go ahead and combine them into the same fraction. So I will need to have a common denominator. So you got to ask yourself, what do I need to multiply here? So that way I can get a x squared minus 1 to the positive 3 over 2. And remember with exponent like this, you're not multiplying the exponent, you're adding the exponent. So 1/2 plus what fraction will give me a 3 over 2. Well, it would need to have a 2 over 2 or just a 1, okay, exponent. So I'm going to multiply x squared minus 1, 2 over 2 on the top, x squared minus 1, 2 over 2 on the bottom. And then what ends up happening is x squared minus 1, 2 over 2 times 1 is just x squared minus 1 to the 1 power, okay? Minus x squared, right there, over, now this 1/2 plus this 2 over 2, like I have here and here, equals 3 over 2. So I have a common denominator now, and it's x squared minus 1 to the 3 over 2 power. And I can see that I'm going to cancel this x squared with this negative x squared. So my y prime is just negative 1 over x squared minus 1. And now I could put it back into the radical form with a power of 3 exponent squared. And that is my answer. All right, guys, I wonder if we actually did the product or quotient rule, if it will actually stay the same or if you actually have a different answer. So that'll be interesting to see. If you want to give it a try, go ahead. It'd probably be the same answer, but it's probably going to be like a different version of that answer. All right, I'm next going to have you guys take a look at these problems right here. There are 6 problems on the chain rule. You can go ahead and practice this on a separate piece of paper. And I have a video that accompanies this.
Leibniz notation and the chain rule. Let's recall the definition of the derivative. We write the slope of the secant line through x f of...
Yeah, I don't care about that. Okay, sorry. So I'm going to go ahead and just start at the chain rule right here.
equals du dx times v minus u times dv dx all over v squared. The chain rule. This is about differentiation of the composition of 2 functions f and u. The derivative with respect to x of the composition f of u of x equals f prime of u of x times u prime of x. Written in purely functional notation, the derivative of f composed with u equals f prime composed with u times u prime. Now, in viewing a composition such as f of u of x, we will think of f as the outside function and u as the inside function. Examples. The derivative with respect to x of x squared plus x quantity cubed. Here, our inside function should be thought of as x squared plus x, and the outside function, f of u equals u cubed. The derivative of the outside function is f prime of u equals 3u squared, so we write 3 times u of x squared, and u of x is x squared plus x, and then multiply by the derivative of the inside function. Let's look at the derivative with respect to x of the square root of x squared plus 1. Here we think of x squared plus 1 as the inside function. The outside function is f of u equals square root of u. The derivative of the outside function we know is 1 over 2 times the square root of u. So we write 1 over 2 times the square root of the inside function and multiply by the derivative of the inside function. Simplification here gives us x over the square root of x squared plus 1. More examples. Let's take the derivative with respect to x of sine of 2 pi x. Now here, our inside function is simple. It's simply the constant 2 pi times x. The outside function is f of u equals sine u, whose derivative is cosine u. So we write cosine of u of x, or cosine of 2 pi x, and then multiply by the derivative of the inside function, which is the constant 2 pi. So we have 2 pi times cosine of 2 pi x. Let's take the derivative of cosine squared x. Let's be sure we understand that what this means is the square of cosine x. So our inside function is cosine x, and our outside function is f of u equals u squared, whose derivative is 2u. So we write 2 times the inside function cosine x and multiply by the derivative of the inside function minus sine x. So we have minus 2 cosine x times sine x. The derivative of 1 over 1 plus sine x quantity squared. Here we view 1 plus sine x as our inside function, and the outside function is 1 over u squared, or u to the minus 2 power, whose derivative is minus 2 u to the minus 3 power, or minus 2 over u cubed. And so now we write minus 2 over the inside function cubed and multiply by the derivative of the inside function. So here we have minus 2 cosine x over 1 plus sine x cubed. the composition of three functions. The chain rule here says that the derivative with respect to x of f of u of v of x is first f prime of u of v of x times the derivative with respect to x of u of v of x. Now applying the chain rule again, the derivative with respect to x of u of v of x is u prime of v of x times v prime of x. So we've basically just applied the chain rule twice here. Example, the derivative with respect to x of sine squared 3x. Now the innermost function here is 3x. So let's let v of x equal 3x. Now, So let's let v of x equal 3x. Now, 3x is inside of the sine function, so let's let u of v equal sine v, and the outermost function is f of u equals u squared. Now, the derivative of u squared is 2u, so we write 2 times sine of 3x and multiply by the derivative of sine of 3x. The derivative of sine v is cosine v, and so we write cosine of 3x and then multiply by the derivative of 3x. And since the derivative of 3x is 3, we end up with 6 times sine of 3x times cosine 3x. Now, once one is familiar with the chain rule, you rarely go through so much detail. Let's look at how we would actually do this on paper once we understand the chain rule. The derivative with respect to x of sine squared 3x. The outermost function is the square function, so we write 2 times sine of 3x to the first power, and then multiply by the derivative of sine 3x, which is, again, using the chain rule, cosine 3x, times the derivative of 3x. Example, the derivative with respect to x of 1 over 1 plus the square root of x squared plus 1. Now the innermost function here is x squared plus 1, so let's call that v of x. This function x squared plus 1 is inside the function u of v equals 1 plus the square root of v, and 1 plus the square root of x squared plus 1 is inside of the function f of u equals 1 over u, or u to the minus 1 power. The derivative of the outermost function here is minus 1 over u squared, so we write minus 1 over u of v squared, or 1 plus the square root of x squared plus 1 squared, and multiply by the derivative of 1 plus the square root of x squared plus 1. So now we're looking at the derivative with respect to x of u of v. The derivative of u with respect to v is 1 over 2 times the square root of v. So we have 1 over 2 times the square root of x squared plus 1, and we multiply by the derivative with respect to x of x squared plus 1. That's v prime of x, which is 2x. And so finally we have this product. We can cancel 2's here and write the derivative as you see it here. Now again, let's just look at this in its simplest form. To take the derivative with respect to x of 1 over 1 plus the square root of x squared plus 1, we first identify the outermost function here as being the reciprocal function, or u to the minus 1 power, differentiate that function, writing minus 1 times u to the minus 2 power, identify the inside function 1 plus the square root of x squared plus 1, multiply by its derivative, which is 0 plus 1 over 2 times the square root of x squared plus 1, and then identify the inside function x squared plus 1 and multiply by its derivative, 2x. Cancel the 2's and write the derivative in its final form. The chain rule in Leibniz notation. For the composition of two functions, recall that our previous form for the chain rule is the derivative with respect to x of f of u of x equals f prime of u of x times u prime of x. Now let's omit the x dependence of u and write derivative with respect to x of f of u equals f prime of u times du dx. Now if we define the dependent variable y to be f of u, then we can write the left-hand side of the equation above as dy dx. So dy dx equals f prime of u, which is the same as dy du, times du dx. So the chain rule takes a very interesting form here. Notice that if the two factors on the right-hand side were actually fractions, the du and the dx would cancel out, making it clear that the right-hand side is actually dy dx. But these are not fractions. We don't have any independent meaning at this point of the numerators and denominators of these expressions. But nevertheless, that provides a nice way of checking to be sure that you have written the chain rule down correctly. For the composition of three functions, the derivative of f of u of v of x is f prime of u of v of x times u prime of v of x times v prime of x. Let's think of the function as a sequence of three steps. Given an x, we calculate v, or v of x, and from...
Okay, I'm going to go ahead and stop right there and get us back over to our PowerPoint. Okay, so hopefully that went ahead and went over some of the examples right there. Let's go ahead and focus in on the chain rule of you guys applying it and then practicing with the calculus puzzle. So go ahead and start working on this. This is actually the last part of today. So as a quick summary, we did the following. We went over 5 of the examples with the chain rules together. These 5 examples right here. And then after that, you guys went ahead and did some practice using these ones right here with the video. And now you're going to go do some additional practice with the calculus puzzle. If afterwards you want to try some more, I do have some questions from the textbook right here as well. And then I have my answers from the textbook with some of the steps right here. All right, you guys, I hope you have a wonderful day, and I will see you guys next time. Have a great weekend, and as always, be safe and healthy. Take care.